Hello, hello, hello. Unfortunately, I got the time for advent of code an hour off. Was still thinking I was in Eastern, but I'm not, so about an hour late. So not live, but figured I'd still record my attempt for the experience. So got my code here. Well, I don't actually have my code here. Let's get my code here. Do go template here. Now I have my code here, and I'm ready to go for Advent of Code Day 5. Let's see what we got. Interesting. So we have a thing split up into another thing. Let's see what we got. Ordering rules. Okay, so 143 for this first example. Let's split it up by what it is. So cost first, second, data split on the blank new line. Then we'll figure out what all these mean. Page ordering rules means that if an update includes this and this must be before that. Okay, I think I just passed this to literally dot sort. Awesome. Okay. Update consists of those ones. Okay, so let's break those into things. Cost comparisons equals first dot split new line dot map L dot split vertical pipe dot map number, and then cost. What are these second ones? Updates equals second split new line, then for each line split on the comma, and then map all those to number. I think, yeah, we have these, but we just do with them again. Let's see. On the middle page number of each correctly ordered update. So it lists out 3 examples. When I have 6 things. The first update is in the right order. Okay, so I need to determine which ones are in the right order. The 4th is not in the correct order. The 5th is not. The 6th is not. Okay, determined which ones are correct and then get the middle. Gotcha. So, correct updates equals update stuff filter. And what are these? What are these? Pages. False, I guess. So I'm thinking if I pass this to a dot sort and the resulting doesn't get changed, then we're good. That's kind of my theory. Sorted pages equals pages dot sort A B, and let's see, 75 is correct because there are rules that put each other page after it. Okay. So now I kind of need to look into comparisons. I think I'll just do a dot find in it. This is interesting because I need this to detect on the left and the right side. Okay. Comparisons equals comparisons dot find comp includes A. I need the same for B though, right? And then how do I compare these comparisons? Because they might not be on the left, right? It's like in this one, they are all on the left. but then being provided also 47. Well, maybe we provide two arbitrary ones. That's all that matters. It's before and after, right? Okay, interesting. Let's see. So maybe if I change the data structure a little bit, so that way when I have a number, I know what must be before it and I know what must be after it. Const befores and afters. So let's try this for const before, after comparisons. Let's say I'm trying to imagine what I want this to look like. If it looks like an object where you have, let's say, 47. Let's say we have before 1, 2, 3, and then after 5, 6, 7. I think that's what I'm looking for. So it's really just for both of them, but they do have relation to each other. So if not before, in, before, and afters, before, and afters, before equals, after, and then we'll go ahead and put that in there. So befores and afters, before, and which one do I put this into? The dot after or dot before. So if I'm getting, let's see, 4753, 47 must be before 53. So 47, I think. And then it's the inverse for the other side, just so I can have them both in existence. Not there. I just want to see if the structure got built correctly. Yeah, really. Doesn't look right. There we go. Okay, looks a little better. So, I want to look at 47. Hey, show me what's in there. Don't TypeScript me right now. Okay, good enough to show me what's going on. So 47 must be before these two numbers, right? 47 must be before. Okay, these looks like they've inverted themselves. So how about that? 47 must be before. Dang it. I feel like I've just literally done nothing. Yeah, it's not doing what I wanted to. 47, 53. So 47 must be before 53. That's not the way it's supposed to be. I feel like if I just invert this, it does nothing. Okay, there we go. 43 is before 53, 13, 61, 27. So if I do 47 vertical pipe, I'm going to see a few of these. Yeah, okay, I think this is what I was looking for. So now that we have this, we can see which ones it should be before and which ones it should be after. So again, this isn't coming perfectly to me. If we get a number, if we check that everyone after it is after it. So I don't think we're going to get a cool sort out of this, to be honest. Can't see it in my mind. But we can go through each one. So for let I 0 I less than pages dot length I plus plus. So const page. Then we go through all the ones before and all the ones after it. So const is before equals pages dot slice 0 up to I. Const is after pages dot slice I to the end. So if we break this really quickly, just set I to 2 so we can see this. We can see page is before is after. So we're looking at 61. Right? And before it is 75.47. And after it is 53.29. Ooh, plus 1. There we go. Okay, this is good. So now that we have all of these, I can put this back to 0. I can make sure this is valid. It should be before. We'll see when I actually do get this out, I suppose. Trying to follow it. So, befores and afters page. Before, I guess should be after. Yeah, it's gonna be interesting. So page should be before. That's not the one I wanted. Yeah, why this break isn't killing me sooner? Oh, because the inner dot filter. Sure, we'll survive. So 75 should be before all of these. So 47, 61, 53, 29. 41, 60, 47, 61, 47, 61, 53, 29, 53, 29. Where the heck did 13 come from? Did 13 attach itself incorrectly to 47? No, it's right there. No, I'm looking at 75. What the heck? Seventy-five 13. It's right there. Why? Oh, it's only comparing it to the other ones that are in this list. Right. Okay, that makes logical sense. Yeah, so I have this. I have what should be. I just have to make sure the other list doesn't contain the other thing, really. So, is before, is after, should be before, should be after. Ah, my mind. There are rules that put each other page after it. Blueprint 75 before 797, which violates the rule. Ah. Whew. I am not on it today. If is after. Basically, it's a sum and then a has. So it should be before some of these. Before is after includes before. return false. And same way for the opposite. If should be after any of the befores. Return false. Yeah, I think that's what we want. It's hard to see though. Otherwise, congratulations. You're good. None of them. That's absolutely great. Then it's just return the middle one, not just return them arbitrarily. Okay, so they're all hitting the falses. This is very sad. Pages, page, before is after, should be before. Okay, can we just do the first one? There we go. Let's just do the first one, right? So we're looking over this one page 75. None of these should be before. So should be before is all of these. We have an inversion. Goofed up above, I think, when I did this. I better not all be making it through. So I have 75, 97, and 75. Okay, so the three are properly making it through grossly. Very grossed out by this, but it's happening. And then we just need to get the middle. Luckily, y'all are evened. So return map pages, pages dot length divide 2. Then what? Reduce, send them together maybe. No, that's not how you do this apparently. What did I mess up on? Is it this part? Is someone not divisible by 2, 3, 4, 5? Yeah, that doesn't work. So 1, 2, 3, 4, 5 divided by 2 is 2.5. I floor it to get us 2? Yeah, it looks like I floor it. Okay, working. And then we have this being angry. Wow, that probably goes. I don't have an input yet. Let's grab that. We have an input. Hey, what's going on? Can I read undefined split? Oh, great. I have weird Windows things in here. Let's get rid of them, please. No weird Windows things. Awesome. That's number. Not too confident in it, to be honest. Okay, never mind. I am very confident in it. Reach the incorrectly. Use the things to do them in the right order. Dang it. Okay. So yeah, we actually do have to do it in the right way, which is I was hoping we wouldn't have to, because it's not seeing it fully without pulling out sort and getting this working however it should be. So fix them and then do them correctly. Hold on, what's this? You add up the middle page numbers after correctly ordering just their inputs. Oh, okay, so it's some just the ones you fixed. Okay, it's not too big of a change. Let's grab, I guess, same problem. It's the same input for 2, but I only target the broken ones. Well, I don't expect the sum of the broken ones, rather. So give me that. Correct updates. So it's actually incorrect updates. True. False. And now we should have not an incoming message. The incorrect updates. Okay, this is good. We have them. The 3 bad ones, and now we need to fix them. No, what the heck? Don't in conference party. So I think we might have to be calling the dot sort somehow. Interesting. Interesting. I mean, we're gonna see what happens. Sort A, B. Is it basically if so? We are relying on the logic of our orderings to be logical, as in we'll never get an instruction that one thing should be after something, and a conflicting logic. So our logic is const should A be after B, which will be looking into the befores and afters for A, and const should B be after. Because there's 4 possibilities here. If A and befores and afters, log befores and afters A, which is going to be true for I think both of them. Right, so A, B, so 97 and 75, right? They're going to be looking at each other. And let's kind of trim this a little bit. Well, we can't trim it that much. Can't trim it that much. Yeah, we're getting too into the beef here. So 97 and 75. 97 needs to be before all of these ones. 75 needs to be after these ones. Alright, so now which way I go, the way I've divvied up the data structure, they will always have equivalencies. Okay, so basically, and for 97, 75, 75 vertical bar. Will help if I type the right number in. Crazy. What am I looking at? 97, 75. Okay, must be looking for the other one. Ah, here it is. So 97 should be before 75. Which is another way of saying 75 should be after 97. Or 97 should be before 75. Yes, there's different ways of saying the same thing. So we'll just go for it one way and see how it works. So if befores and afters A, so 97 includes, well, before includes B, that's -1. And then I'll do the inverse to say +1, but the inverse will be identical. Let's see what the script updates end up looking like. What should it look like? 47. Why are you highlighting that? Oh, 97, 75, 47, 61, 53, 61, 29, 13. Okay, looking good. 97, 13, 75. 97, 75, 47. Okay. So, just kind of need to do more on this. I need to figure out the condition to return 1. I don't think just writing it backwards and saying after. I think what we need is the else down here, because these ones need to be handling themselves perfectly. Go. So we're looking at 47, and we're looking at 97. These don't overlap. Why do they look so much the same? Yeah, they do. 47's in the B. I'm comparing 47 and 97. Oh, they are. They're right here. Okay, so it's in the after. I need to return something else. So I'll do it another conditional, I suppose. If after includes B, returning a 1 at this point. It's not ordering the second one, though. I'll get these up for test cases, at least. Correct ordered is right. That one. It's not going to be scanning this with my eyeballs every single change I make. Now, fixed updates. Updates I stringify updates equals correct ordered I also JSON stringify. There you go. So if they're correct, they're correct, and I can look at the fixed ones. None of them are fixed. Well, I think I've just goofed this up with a fill. Great. When he says all of them are fixed. 97, 75, 47, 23. No, okay, never mind. They all look correct to me. Let me remove this. Okay, maybe it was working the whole entire time and my eyes just deceived me. Let's do the thing where we return whatever it is we're supposed to do. This is valid. Why are you angry? Cannot find incorrect updates. Oh, I can't type things correctly. Okay, that's a number. Hey, gotta put this in like 2 minutes ago. Ah, dang it. Okay, I made it though. We made it. So, we got it in there. Woo! That was a little dicey there. Was not confident in the figuring out the proper sorting to get that working, but I kind of fumbled my way into it at the end there. So we're going to go ahead and commit what we got here. And then see what we can do about trying to explain this, which no promises. Go. Day of 5. There we go. So, the challenge. I think it was actually simpler than I ended up taking it, but just did not see the writing on the wall. So we're first given the input of 2 different things. Our goal here is to process each of these lines and to do something with that process. The first in part 1 is to determine if these pages are correctly ordered. And then if they are correctly ordered, add up the middle page of each of the list and return that sum. What determines if they're correctly ordered isn't, of course, the numerical value comparative to each other. That'd be too easy. What determines if they are correctly ordered is a special hard-coded list of these things should be before these other things. So 47 should be before 53, but this is also saying that 53 should be after 47. So when we see 75, for example, it is before 47, 61, 53, 29. That's what it is. And then based on the rules above, it should be before 29, 53, 47, 61, and 13. And it should be after 97. Now, if where it's at relative to its other friends, if that is a true statement of where it is and where it should be, then it's good and we continue on. We fail on these ones because they start violating the rules, where it's a good example. 75 is before 97, but the rule says 97 should be before 75, or to put the subject first, the 75 should be after 97. So it allows us to determine the wrong ones. And then part 2 was to take the wrong ones and actually put them in the correct order based on everything we just discovered. And I ended up doing that in a way. I don't like the way I did it, but it ended up working. So let's figure out what I did, and then we can try and do some refactoring. I'm not going to have a lot of hopes here because my head did not fully wrap around it. So, first I just did the old input parsing, parse the inputs. So I split the data into the data on the top, the data below, by splitting by the blank new line, handling the weird Windows Z things I had. Then I turned the comparisons into an array of tuples by splitting by each line, and then each line splitting on the vertical bar right here, then mapping each of those to a number. Then I did the exact same thing for the updates, but splitting on a comma to turn them into arrays of numbers. That was all the easy parts. Then I thought it wise to create some freaky data structure here. We'll try and see even if this is accurate, because when I created it, I had a vision, but when I used it, it ended up looking a little different. So, for example, my goal with this was to be able to look up, basically not have this be an iterative solution. Every time you want to look something up, it's O of n, O of n, O of n, O of n. I wanted to O of 1 all these lookups, so I spent the memory to do so. So my theory was that if I look up 75, I'll be able to figure out all the numbers that should be before it and all the numbers that should be after it. So let's see how close I actually did on that. So 75 should have all these numbers before it. No, 75 itself should be before all of these numbers. And 75 itself should be after 97. Yeah, so the way I've written it and the way I mentally mapped it, they kept going back and forth on me, which is the unfortunate source of my confusion. Yeah, and then based on that confusion, should be before, I tried to do effectively the comparison of these are like it should be this way and it is this way. So for all the ones it should be before, or ones that should be before the current number, yeah, as you can see, this is where the names got inverted because Englishly speaking, this should be checking the opposing array, not the exact same one, but the names are all wrong. So let me walk through. This one never gets hit, which is weird, but okay, it's fine. I'll walk through this one. So we're looking at this one. And we don't need to look at the before since they're not in this equation. So we're looking at the number 75, and it is wow, no wonder. No wonder everything is hard to read here. Even these are named incorrectly. Ooh, I couldn't name a thing to save my life. Okay, this is getting a little better name-wise. So if we look at, then let's just look at all of them too while we're here. Pages. So if we're looking at this array, 75, 97, 41, 61, 53, and we're looking at page 75, let's just show these while we're here. Is before, is after, should be before. There we go. So we have reality and what it should be. So, what is before 75? Nothing. What? Ah. Yeah, as you can see, I'm not completely on it. This is what's after. Is after page. Is before page. Okay, let's try this again. So, we're looking at page 75. What's before it? Nothing, because this is an empty array. There's nothing behind it. What's after it? The rest. 75, 97, 40. What? 97. Oh, yeah, so it's this failing one we're looking at here. Well, that eventually fails, of course. So yeah, these are the ones after it. Now what should be before it is all of these. What should be after it is 97. Now this is one of the ones they walked and they said it was a failure. It would print 75 before 97. Yeah, I have really failed to mentally map what incarnation is going on here. So we have 75. All these numbers are after it. 97, 47, 61, 53. The naming of this. So if I look at 75, it should be before all of these. Yeah, I see. It's the naming that's really tripping me up. So it should be after all of these. My should be and is just really confusing. This is why names matter. Is, should be, if anything, it feels like these need to be inverted. So maybe I go up to these names and it'll help me follow it. So 75 and a bunch of befores. We have one after. So instead of calling it after, well, it's just instead of calling this one after. So 75 should be after 97. Can we at least say that? Yes, we can. So 75 should be before all of these ones. Yeah, at least it's slowly starting to combine here. Slowly filling in to the way my mind is actually mapping. This isn't is after page. These are things it is before. That's why I renamed it before, because this is what's actually going. Pages is before. There we go. How about that? Page is after. Okay, this is starting to get there because these are the pages. The page is after. Yeah, so if you are before, but you should be after, then yeah, now these names are starting to get where they should be. Still not pretty, but it's starting to be easier to follow. Still gross though. So is after is before, should be after, right? So now these make more sense. If any of the ones you should be before you're actually after, then yeah, you're illegal. Same for if any of the ones you should be after you're actually before, should be illegal. So yeah, this is keen intellect. Now, one thing we can do here is we can make these sets to make those includes go a little faster. And then instead of these empties, new set. Just like that. Instead of some pushes, do some add. And then, oh, these are the ones we're actually doing inclusion looks on. So if we invert this, which I haven't done an inversion like this in a while. So we want all of them to not be in here. So if not all of y'all aren't in this, I think that's what we're looking for. Let's see, worst comes to worst, I'll just put it back. Okay, yeah, I have goofed that up. Do I need to make these absolutes? Nope. Yeah, I've not inverted this accurately. I can send them both back to sums. Okay, yeah, that's the way it needs to be. Make sure this number is still that number. Where's the number? 6267. Okay, there we go. So, little version of who's looping over who. Let's have the one that is in these constant lookup times. Big fan. Okay. Oh yeah, that console log ain't pretty, but it's working. Okay, so we have these. They're doing their job for detection purposes. I think I'm gonna go to, yeah. So these are properly figuring out which ones are correct, and then mapping over the correct ones, getting the middle digit, flooring it if necessary, because we can't do 2.5 as an index and then adding up all the middles. And then for part two, it's almost all the same. Actually, it is all the same. You're still getting all the correct ones, but then we target the incorrect ones and we actually sort them like so. And I believe this is going to make more sense when we do our refactor, but we haven't actually done that. So, but this is using the before and after relations to return -1 and +1 based on based on the actual relation, which is how the dot sort method works. You return negative number to say A comes before B, positive number to say the inverse, 0 to say they're basically the same. Their order is equivalent. Then I just had this validation checking here. So what we want to do is have all this first half in a method that just returns the correct ones and the incorrect ones, and then let our basic function do whatever we want for that. So function categorize updates. Get your data string, and it's gonna be all of these. And instead of doing a filter, I'm just gonna put them into 2 arrays. Correct is here, incorrect is here. And if I want, I can actually put the corrections into incorrect, but I'm just gonna leave them as incorrect because that is something that just part 2 wants to do. So let's loop through it and put them in the correct arrays for updates. This is for pages of updates. And instead of a filter, maybe we're gonna want to filter at some point, but just make a cute little function. Function is update correctly. Is update correctly ordered or are updates? Ordered. There we go. And we're going to need to take the updates, the number array, along with the befores and afters. Isn't the greatest name for this? But I'll keep it like so because I haven't thought of a better one. But there will be a better one, and we'll figure that out soon. Boop. So we can go into here through all of our updates. Our returns are in there that are telling us exactly what it was before. So it's going to be if our updates correctly ordered. Our pages. We'll figure out naming in a moment. Oh, not before. Just give me the holes. Correct dot push pages. Else incorrect dot push pages. Boom, we got that. And then our generic function is going to return them both. With that, of course. So now that we have all this information, solve 1 is just going to use the corrects. data just alike of that. Beautiful. Solve 1 loves it. Now let's head on over to solve 2. Well, we'll do the same thing for incorrect. And the befores. Categorize updates data. Oh, great. I've used the same name for a bunch of things. That's not going to be annoying. Befores and afters. Should be before. Should be after. Has. And still works like a charm. Drop all these weird prints. Yeah, 5184. 5184 is still working. Okay, so it's angry a little bit. Oh, I'm returning undefined at some point. Don't worry about it. Okay, there we go. It's a little bit more readable. And now that we're actually using the new names, if A should be before B, then 1. If A should be after B, well, I said -1. -1. If A should be after B, B, 1. Now, yes, I could have done in this case do if B another should be before A, then that does the exact same thing because this is effectively bidirectional. Though it's not a graph, but you can look up one thing to find the other and the other thing to find the one. Costs double the memory ish, but allows all those O of 1 lookup times. But the story is told from the perspective of A. That's where the story comes from. And then 0 for the base case. I love it. Not a fan of the for each, to be honest. 4 const pages of incorrect. Boom. Much better like that. And you know what? Yeah, I'm fine with this. This here can be functioned away. So function sum middle pages number array, just return that. Which there we go. Some middle page. It's a number array, I just realized. There we go. Because both of y'all do this. Boop. And then you'll do the same for your corrected incorrects. Love it. Now, I do have a choice here. So we have what turns an unsorted one into a sorted one, this logic right here. Then we have in here what detects if something is correct or incorrect. I can, now that I've written it, just use that part 2 code to determine which things are originally correct and incorrect by just checking if after I sort it, they're in the same order as before I sort it. Of course, the price of doing that is that I'll have to run the sorting algorithm on each of them. There's no chance of early termination. The pro of that is that there's less code to maintain. We don't do this fun bit of slicing here, which is expensive. I can make it less expensive by doing it incremental sliding window style. Let me first just see if that theory works. So let me take this cool function that is right here, and let me try and shove it up here, see if that does work. So it's basically, instead of this, well, actually, it is, we'll still use the function. The cost pages raw equals JSON stringify pages. Then it's returning cost pages sorted equals dot 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 pages dot sort, like so. And then if they're the same, pages triple, come on, equals JSON dot stringify pages sorted. So if they're the same, congratulations, they're correctly ordered. If not, everything has failed. And as we can see, everything is still running correctly, so that does work. Don't think it's as... Yes, this is more complicated just because there is more code and we're not kind of cheaping out and using the sorting algorithm. I like it, honestly. So I'm gonna go with that. And I'll just build up these. Oops. These two arrays here. Like so. And I'll just add to them and remove to them instead of building with slices. So is after, I just always push I minus 1 if I is after dot push pages I minus 1, like that. And then is before, I just remove the 0th element. Right? Let me follow this through. Pages slice I plus 1. So it's everything after I guess is before. My mind's blanking on this. It's all of pages. And then I should remove myself. So is before dot slice 0, 1. Yep, everything's still passing there. Okay, yeah, so this is just, doing it in a more memory efficient way instead of calling slice on this big array of pages. It's not that big, but you just have this in memory, you add to it, you remove to it, a la sliding window. I'm doing a splice here, which is gross. I'd rather do a pop. So if I reverse this, I can say pop instead. Which still works like a charm. So now it's truly a lot more efficient. What about this is after? I was pushing, yeah, we kind of need that one there. So yeah, big fan of it. We have these, we have should be before, we have should be after, is, some, should be, yeah, either of these. Honestly, go straight in here. It wouldn't be a big sacrifice to readability, honestly. So I like that. Can we go to an dot every? What do we use the index for? We use it for manipulating this outside state. Yeah, I think we can go for an every. Let's go for an every. Turn pages dot every page I. Still need this logic. All right, here. And then done something wrong. Oh, TypeScript is being angry. Still works like a treat. Now, let's see if we can invert this to just being able to return this directly. So we're returning a false. I want to be able to return a true. So I swap it to every and I swap to ands. Let's see about that. Yep, everything's on fire. So let's try the every first. And let's try the and. I might also need to do an every not. There we go. Full inversion of the operations, the individual operations, and the comparison of the operation. How much readability did I just sacrifice, though? It was relatively readable before, but now what am I looking at? Ignore the state manipulation. So, return everything that's after is not should be before. And everything that's before is not should be after. So if I should make those names better, that'll help a little bit. Is before, it's not should have be after. I think it's a little cost in readability, but it's, I think we gain the readability on it being an every. We can clearly see what's going on there. Okay, I'm liking this so far. Let's make this go even better while using this to determine which one we push into. So push pages. Oh, is this too much for it? Oh, because these are typeless, right? Number array. There we go, much happier. Now, based on which it is, we push into whichever one that is. So those two can live there. We'll leave the updates to there. Let's bring... these do belong here. Okay, one thing I'm not happy with is the name of the heck of what befores and afters. I want to think of a cooler name for this. Comparisons, relative relations, number relations, page relations, page orderings, relative pages. Because logically I'm saying, hey, 75, what should you be before and what should you be after? Can't really think of a good name for this, unfortunately. It escapes me. What do they call it? I'm gonna steal their words. Ordering rules. Good enough. Page ordering rules. Now let's see if I can be a little cheeky here and get some free TypeScript usage out of this. So I want this to be return type of categorize updates. Aha, you can't stop me. Love that. Let me change these into asserts. So I should have done it earlier, but I didn't because I was lazy. 62, 67. There we go. What's our second one? 51, 84. Make sure those are still the same. That they are.
I'll leave that in there. So, this, I believe, is as far as I will refactor this. So, let us break it down once more. So, both of them go through the categorization of updates, part 1 and part 2. This does is it splits it into raw comparisons and raw updates, which is just the strings before and after the double new line, just right here. And then for each of those, we turn comparisons, raw comparisons, into actual comparisons. So a tuple of two numbers split on this vertical bar. Then we turn the comparisons into page ordering rules, which is going through the before and after and adding should be before or should be after to each one. So if I look in page ordering rules, let's pick one we haven't looked at actually. 61. Don't know what's in here, but we're going to look at it. So 61 should be before 13, 53, and 29. And if I look at this 61 vertical bar, I match all of them, I can see it should be before 13, 53, and 29. And it should be after 97, 47, 75, which if I search it invertedly, see it is on the after side of 97, 47, 75. The reason for converting it from just an array of before and after tuples into a hash map of sets, effectively. So that way, when I want to figure out, hey, how should 61 be treated? Like, what should come before it? What should be after it? I don't have to search for this entire thing and determine which side it's on, determine if it's a before, if it's an after, pull out the corresponding sibling. I can straight up just ask this little hash map, hey, what should you be before and what should you be after? And that gives me the values accordingly. So it's a O of 1 lookup there. And if I want to look up anything that is in here, it's another O of 1. So very fast. And then updates just gets turned into an array of numbers. Then we create a correct and incorrect slot to store our updates, and if the pages are correctly ordered, they're going into correct. Otherwise, they're going into incorrect, which takes us to our next fancy function, where we go through each page, keeping track of the ones that are it is after and is before. So initially it's after nothing because it's the beginning, and initially it's before everything because it's not a page. For every page, we update these accordingly by adding what the previous one to what it's after and removing the what it was before from, well, it's not before anything anymore. So we pop that away. And we figure out what it should be before and what it should be after. And we make sure that everything that is after it is not what should be before it. And everything that is before it is not what should be after it. Basically, just making sure if you are 75 and all of these are after you, make sure none of these should be before you. The 75-97 example actually makes the most sense because the one we fail because the rule says 97 should be before 75. But if we look at it here, we'll look at 75. The rule still says it should be 97 should be before it. But we look and we see what's after it, it includes 97. So it breaks that every check. It makes us return false, which every would return false early and say it is not correctly ordered.
and that just does categorization. Once they're categorized, well, it depends on what the individual part wants to do. They both eventually want to sum the middle page, but for part one, we just want to sum up the middle pages of all those that are correct. So for every page of updates, we grab the middle one, floor the length divided by 2, and then use the old reduce trick to add up this array of numbers. And then for part 2, well, we want the incorrect ones, and we want to make them correct. Which, since we have all of these page ordering rules, if A should be before B, then we return -1, which is the rules of the comparison function when you're passing it to sort. But if A should be after B, then we return 1. And then it doesn't actually ever come up. We're lucky, I guess. But if they don't have a relation between them for whatever reason, you just return 0. And again, we could have used this with some basic, hey, did you change anything for our detection way up above? But I like what we have up there. So we sort all the incorrectly sorted ones. They are now sorted. And then we just get to sum up their middle pages, which is the exact same thing we did for the correct ones, but now we're doing it for the incorrect ones. And that is this problem. It's a pretty neat one. Like I said, definitely had me going for a loop there, and I instinctually knew what I wanted to do, but all the names, all the flip flops had me going back and forth of naming and actual. I could see, some kind of visualization being nice for understanding this, but given how much effort it took me to write the real thing, you won't see one of those coming from me on this one too quickly at all. And with that, that is Advent of Code Day 5. Hopefully, I will not make this hour off mistake, and I'll actually be doing this live next time. But worst comes to worst, a live solving, a recorded solving is the best we'll get. So until next time, have a pleasure.